Welcome back to Project Polus. In the previous lesson, we covered the resource adequacy plus merchant arbitrage cases. In the currently selected case 7 from our previous lesson, we assumed an accelerated decline in effective load carrying capability, which is effectively a lender stress test. You can see how that assumption tightens cash flows and pushes lender metrics like DSCR and LLCR into more distressed territory. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the model start file for free and build a model alongside me. Link is in the video description below. In this lesson, we will stay in monetization pillar 1, but we'll now move to the final contracted capacity structure, an auxiliary services contract combined with merchant energy arbitrage. Here's the setup. We're looking at a 1-hour 200 megawatt battery. 120 megawatt are contracted under the auxiliary services contract, and the remaining 80 megawatt are exposed to merchant energy arbitrage. And we're going to run the same lender versus equity logic you have already seen. In the debt base case, lenders apply a 20% haircut to merchant arbitrage revenue. In the equity base case, equity assumes no haircut. On top of that, we'll run an equity sensitivity where operating performance is stressed. Availability drops to 94% and curtailment increases to 3%. Now let's implement these cases in a model and watch what happens to the dashboard outputs and equity KPIs. Alright guys, now we are back in the model checkpoint file from our previous lesson, and let's move to our inputs time independent sheet and look at the inputs that we have given for our next 3 cases we will model together, cases 8 to 10. What you will notice is that in comparison to our previous lesson, we now look at a 1-hour battery instead of a 4-hour battery. That means that our installed DC energy at the beginning of life drops significantly to 265 megawatt hours DC versus 1060 in the previous lesson. You can see that for our case 10, our equity stress case, we have already set up the availability and curtailment assumptions. So once case 10 will be selected, we will have an availability of 94% and a curtailment of 3% instead. Let's move further down. Now from a revenue stack perspective, let's actually select case 8 for now, so you can see what is going to be turned on. We now have our auxiliary services contract active, as well as our merchant energy arbitrage. So both of these revenue stacks will be active for our full asset life, meaning 120 megawatts will be contracted for a period of 20 years, and the remaining 80 megawatts at the point of interconnection will be merchant. You can see that input right here. Then let's move on. Now from an augmentation standpoint, you will notice that again, we will have a 20% headroom increase once the augmentation is triggered, but the augmentation trigger itself will be again 4%, so that should be sufficient versus the 5% in the previous lesson. And our target major maintenance reserve buildup will be 3 years instead of 4 years again. There's actually a typo right here in the labeling, so let's fix this. Okay. And as always, our first case is our debt base case or debt sizing case, which is the reason why our debt sizing is turned on right here. And our leverage in this case will be kept at 75%. And last but not least, for debt sizing purposes, we have also a merchant energy arbitrage haircut of 20%. So let's move to our inputs time dependent sheet and look at the debt schedule. And you will see for case 8, our debt is still blank. So in the dashboard, we should have a full equity case. Or actually, there might be still some debt applied from the previous selection. So let's run our master macro and make sure that our debt is actually sculpted according to the current case. And you can see now we actually have the hard-coded schedule applied, and our dashboard seems to make much more sense. Again, you will notice a blend between merchant and contracted DSCR in that case. and we are again closer to our 1.3 contracted DSCR over our 2.0 merchant DSCR. Our levered equity IRR in this case is already above our hurdle. So if you recall from our scenarios sheet that in the previous lesson, our levered equity IRR in the debt sizing case was not above hurdle. So that is, from an equity standpoint, already a good sign that we meet the hurdle in the debt sizing case. So let's see how much the uplift will be once we actually turn on the equity base case, which is case 9. And the only difference, according to the information memorandum, was that we do not have a haircut here. But the first thing we will want to make sure is that our debt schedule for case 9 will be applied as hard codes. So to do this, what we'll do is first replicate case 8 in case 9. So copy and paste this input here. Then move up and turn on the debt sizing. Then we will execute the master macro. We get a warning here because right now we are sizing on an equity base case. So that's okay. That should be our only check. Yes. So we are aware that we are right now sizing in an equity base case just to get that same repayment schedule right here. We could have also just copy and pasted it, but that's a good way of checking whether the inputs right now in case 8 and 9 are fully aligned, which is the case because the time series seems to be absolutely identical. Then let's move back. We can delete the 20% haircut and turn our debt sizing off. That means that our debt is now applied from the hard-coded schedule in case 9. So we still have the same debt repayment profile in our senior debt section as the debt sizing case. You can see that if we were to size debt on the current model inputs, we would have more debt service available. But what's actually applied is right here, our hard-coded schedules from our inputs time dependent sheet. So we do not resize debt, even if we execute a macro, because our debt sizing is turned off. Then let's move over to the dashboard. And you can see our levered equity IRR is now actually at 13%, which is 3% above our hurdle. The DSCR profile has a similar effect as our previous equity base case. Our overall DSCRs are much stronger in the early years. And in the year where we now have to start paying taxes earlier, we actually see a drop. And that is also observable in our cash flow waterfall. Here, the orange section are our taxes that we have to pay in the levered case, which now start around year 2037. And if you move back to our debt sizing case, you will notice that the taxes are due just a little bit later. Let's move back to case 9, move to our scenarios sheet, and hit the master macro here to make sure that we are basing it on our equity base case and not our debt sizing case, so that here the high equity IRR is displayed. You will also notice that in comparison to our previous case, we need significantly less CapEx. So right now the 1 hour battery setup costs around $115 million. And prior to that, we paid almost $300 million. So from an equity standpoint, obviously it's important to see how large the asset is, because in the setup of a 4-hour battery, equity would need to put down $94 million, whilst for a 1-hour battery would only be $35 million. Great, then we can move on to our final case for this lesson, which is case 10. And this time we will have an equity sensitivity, although this can also be a debt sensitivity. It doesn't really matter. It's just a sensitivity for either our lenders or our equity investors. And what we will do this time before we flip over to case 10 is pick up this time series so that we have a frozen debt structure. Let's actually pick up the whole series, copy this row and paste it here as values, Alt HBSV, hit enter, so that we have the same repayment profile for case 10. Then we turn case 10 on. And the only difference in comparison to our case 9, which is our equity base case, is a 3% reduction in availability and a 2% increase in curtailment. And you can see that such a minor change can have quite a significant impact on our levered equity IRR, which drops by almost 1.5%. And let's see what's actually happening with our availability and curtailment. So let's trace dependence for this one. That is in the energy section in our operations sheet. And you will notice that our availability and curtailment assumption feeds into our revenue stacks further down in our revenue section. And the first revenue that we will earn is with our ancillary services contract. And right here, our contracted capacity is 120 megawatts or 120,000 kilowatts AC. With the two augmentations that are scheduled, which you can see here in this chart, as well as the MMRA buildup, we make sure that our effective duration never falls below 1 hour. And that means that we never have a nameplate adjustment and maintain our 120,000 kilowatts AC after our nameplate adjustment, so that doesn't drop. But what drops is the availability assumption, so this indeed has an impact on our ancillary services contract. So if the battery isn't available, we will not get paid from our contractual counterparty. However, if the grid operator curtails our asset, meaning the battery is taken off the grid, and it's not the asset's fault, basically, then we would still get paid. And this adjustment obviously always depends on the actual contract, but the model allows for flexibility whether this is included or excluded. Now let's move to our merchant exposure. And here you will notice that both our availability and curtailment are turned on, which makes sense because if the battery isn't available, we cannot trade any merchant arbitrage revenues. And if our battery is curtailed, meaning we are forced to take it off the grid, then we can also not generate any merchant arbitrage revenue. So the curtailment effect actually only materializes for our merchant energy arbitrage portion. And thankfully, in this case, from an equity standpoint, the curtailment on the ancillary services contract doesn't have a significant impact. The only impact that it might have is a cash flow timing impact, because grid operators typically reimburse for lost revenues, and that reimbursement come in later than the actual expected revenue. But that is just a minor working capital adjustment over actual lost revenue. Okay, let's move back to our dashboard. Then one last thing I want to demonstrate is how we sized our augmentation here. So the augmentation schedule is already pre-optimized for all the cases. But if we scroll down to our augmentation section, and we were to say that we reduce our buffer that is installed once the augmentation event is triggered to 10%, hit enter, you will notice that we would fall below our effective duration around year 2042, 2043. And what this would help with is our MMRA buildup, because we wouldn't have to buy as many new batteries. This would actually relieve quite some cash flow in the earlier years, but then we would be in contractual breach later on. And that's definitely something that both the equity owner as well as the lender would want to avoid, which is the reason why here there was a pretty much goal-seek approach of how much buffer needs to be restored so that 2 augmentations are sufficient to maintain the minimum nameplate duration for a period of 20 years. So if we do 15%, we would still get a warning right here. Let's try 18%, that's still a warning. 20% gets us in the green zone. Now if we were to oversize it by, say, 30%, you will notice that is something that equity sponsors would want to avoid. Lenders wouldn't have any issues with it as long as the debt is sized based on that build-up period. But if you would oversize the battery significantly, we would take a lot of unnecessary cash flow out in the earlier years to save up for that augmentation, which would hurt our levered equity IRR quite a bit. So now we would be at 11.1% or 11.17%, while if we select 20% of buffer restoring, we would be at 11.53%. So the augmentation assumptions are always a fine balance between a more aggressive approach, typically carried out by equity sponsors, because they would want to make sure that cash flows come in early, and lenders would want to make sure that the battery can sustain its nameplate capacity for the full asset life, or at least for the financing tenor. Okay, last thing we will do is go to our scenarios sheet and make sure that our case 10 is also picked up. So let's run all our scenarios up to scenario 10 again. Execute run all macro. Hit OK. And now we have a neat output table for both equity investors as well as lenders, where they can compare our 3 different contracted capacity revenue structures, which are aligned with our monetization pillar 1. So all of these cases here reflect monetization pillar 1, which has at least some contracted capacity component. And from an equity standpoint, you can see that cases 1 to 4 are the clear winner, because our equity base case is case 2 and results in a levered equity IRR of 13.8%. And that was our pure full tolling agreement without any merchant revenue, which is also reflected right here. We do not have any merchant CFETs, we only have contracted CFETs. Then our second best contracted capacity case is case 9, where we still achieve a levered equity IRR of 13%. And that is a combination of an ancillary services contract as well as merchant arbitrage revenue. And the lowest performing contract combination in this case is case 6, which is our resource adequacy case in combination with merchant energy arbitrage. And here we have a 4-hour battery, which needs a significant higher upfront investment from both equity and debt, but actually results in the lowest equity IRR. It's noteworthy though that all different cases from an equity standpoint hurdle, because we're above 10% in each equity base case. Alright guys, that completes the final set of cases for monetization pillar 1. In the upcoming lessons, we will move away from contracted capacity structures and move into fully merchant cases, where the revenue risk profile changes completely and the scenario outputs become even more important for decision making. Alright guys, this was it for this lesson, and I will see you in the next lesson. See you there.